Today I'll talk about SQL or SQL, and I'll use this website here to demonstrate the examples. So SQL structure query language is a language that we learn to be able to interface with a relational database. Also, you might hear relational database management systems, RDBMS, and it's the most popular way today to store data. So when you access any website or web app or application in your mobile devices, it will pull the data through the backend from a database, and it's likely it's using SQL. And SQL has many flavors. Uh, for example, there's Microsoft SQL Server, there's Oracle Database SQL, there's MySQL, popular one, and Postgres, which is the one I usually use, and many others. So it's like you have like cars, right? Cars have different makes. In the end, they're all cars. They kind of behave the same, and but we have kind of different flavors or make, right? Toyota makes cars, Ford makes cars. So th those are like the specific implementations of SQL, whereas the entity of the car itself, the blueprint for the car is SQL. Anyway, this website here, you can write your SQL queries, as we call them, in this text box here. The left-hand side is the definition for each table, and the right-hand side are the actual table and their data. So in SQL, we operate with tables, and each table has columns, and we have rows. It's like a spreadsheet, like if you ever used Excel or Google Sheets, same thing. So for every column has a different piece of information. For example, we have a table to store information about the customers, and you would have like a column for the first name, for the last name, for the age, for the country the customer is from, and so on. Whereas each row is corresponds to a specific customer. So this row of customer ID number 1 is for John Doe. He's 31 from the USA. And then we got another row for another customer, Robert Luna, 22 from USA, and so on. Okay, so database has many tables. Each table has columns, and we got the rows. Okay, so we're going to type some query here, which is what we use to communicate or interface with the database. And the language used is structured query language or SQL. The most basic query is called a select query. If you want to ask information about a specific table, and you're going to say select. And I use capital all caps because that's the usual convention we use. Whenever there's a keyword that's specific or reserved to the language of SQL, we capitalize, but it's not really necessary. And I'm going to use star after select space. And usually we select specific columns. So star means all the columns, and then space from space, the name of the table, in this case, customers, and then you finish off with semicolon. And how do I know it's customers? Because it's written here, left-hand side, and I also see on the right-hand side. And I click run, I should be able to see all the rows for the table of customers, and all the columns appear. So this is a small data set. In general, it would be a lot more, maybe millions of rows, if not more. So obviously you can do by eye, but usually that's not the case. So if you want, you can limit your query to just a few rows. For example, I want to limit to 3. So I'd add after the from space limit 3, which means I only want 3 results, 3 rows at most. In that case, it just captures 3. This is useful if you're you're looking at data in your job, and there's some millions of them. You don't want to do without the limit because that's going to probably freeze and crash because just too many records. So you want to limit when you're dealing with actual production data and you're just verifying things. Anyway, I'm going to remove that limit. Let's say I want to capture just people's last names. So I can do that instead of a star. I would write the column name, which is last underscore name. It's important that every character is written with the correct casing and with the underscore, so there's no space there. So you can see last name, we expect to see Doe, Luna, Robinson, Reinhardt, and Doe. Yeah. If you want to include first name as well, what you do is separate the column names with a comma. So you can say either before or after last name. You could put first underscore name, comma, then run the SQL again, and you should see both columns. People like to add a space after a comma just for the readability. That's not important. Okay. So if I were to know, like usually from the point of view, there's different perspectives in SQL, right? You have the perspective of being able to store the data for a specific application. And there's also the perspective of people who are looking to understand the data from the customers. Maybe these people are making SQL queries to find out and answer questions that maybe the business side wants to know. For example, maybe your business wants to know where are our customers from. So somebody would come and make a SQL query and produce a report of the results. So how would we do that? Well, we got a table of customers. So we can look up the country, a column there. So we can select the country from customers. And if I run the SQL, I should be able to see a list of all the customers' countries. Of course, there'll be more than one row with the same country because we got multiple customers from a specific country. And if you're dealing with a like actual data set, it's going to be millions of rows. So that's really hard to kind of count by eye. So what we do is we usually can consolidate these records and eliminate duplicates. One way of doing that is if you have the column name here, precede that with distinct keyword space, you should be able to kind of remove all the duplicate country names. And that would be a lot better. Now I can see there's 3 countries there. So by eye, you can see USA, UK, UAE. So you can produce this report and send it to whoever asked for that information. And there's there's at most 195 or something countries in the world, so that will be okay. If you want to count how many countries there are, you can also use the count function. If you put count parentheses like this, and I would put a distinct inside if you want to make it not duplicate. You can do that if you want to count. There's 3, we are operating right now in 3 countries, if you care about the number of them. So if you want to count anything, just put a count parentheses, enclose that there. Usually people do count star. That's okay as well to count how many rows in the table. But this one, we want distinct country. Okay. Let's talk about the filtering. Sometimes you might need to find some rows by a specific column value. For example, maybe a customer comes in and you need to look up their account information, and they for some reason forget their account number, which is the customer ID. So how would I do that? Well, let's just select all the columns star from customers, but they give us the last name. So the filter keyword is where after from here, and last underscore name, the column name, equals some value under quotes here. Let's say they come in and say their last name is Doe. By the way, it's important I put the capital letter D there, semicolon. So this would narrow down to specific rows whose last name is Doe. But keep in mind, in this world, there can be multiple people with the same names. So it's not a unique match. And that's the reason we have this column here, customer ID, that uniquely identifies each row. So if you go back to this right-hand side, we always have for the tables an ID column that we call the primary key. And that primary key is unique for each row. There can be no other row with the same primary key. So that that makes us be able to have multiple people with the same name and know which one is which. Okay. So here let's say the customer said my last name is Doe, but then okay, there's two people Doe. Obviously there'll be a lot more in an actual production data. So you ask them, okay, what's your first name? I can narrow it down. How do we add where last name is Doe and the first name is maybe John? Well, you just use the and keyword here, and then you just add another column equal value pair. So first name equal, and then John. And then you can run that, and you're going to be narrowed down even more. Because this data set is small, we only have one row match. But I would reckon that an actual data production, you'd have a lot more. So that wouldn't still be enough. So you'd have to narrow down by the age, by the country, and many other attributes, which is really bad because usually you ask the customer for the ideal primary key. So that's what we usually filter by. So if they tell, okay, I'm customer ID, I'm saying I'm David now, David Robinson. Customer ID is 3. So you can right away look it up. Okay, where customer ID is 3. By the way, when you have numbers like this, integer, you don't need quotes. Click run and shoot. Exact match. You know, this one is always exact match. There's only one row with that primary key. Now, each column is a data type. If you look at the left-hand side, you can see customer ID on its right-hand side is this int. That means the data type for that, which is integer. And then first name and last name are both var parentheses 100. What that means is a character varying string, a sequence of characters that could vary in its length. It could be like 1 character, could be 2, and so on all the way up to 100 characters. And the other ones pretty much ints for age and var 100 for country. Okay, so each column has a data type. All right, so one thing I meant, backtracking here for the first name, I told you to put a J capitalized. What happens if I put lowercase? It's not going to work because it's trying to match exactly with the upper and lowercase. But there's a way to kind of normalize that. One way is you either use the upper or lower function. For example, if I were to lower case the first name, meaning all the letters from first name are now become lowercase, so I can compare, and it would always be lowercase. You can do that. That's one way. Or you can do upper, and if you do upper, basically you gotta put all uppercase here because they will always take the first name, make all letters uppercase or capitalized, and then you have to compare the uppercase, kind of normalized version. So that's a technique you can use. Okay. Um, let's see. Let's talk about inserting records now. So we learned how to retrieve data, but now we need to learn how to add new rows to the table. And that's insert into, insert space into. And then you give the table name, customers. And the short version is you can just pass the values by saying values parentheses, semicolon, and then you write them in order as they're defined here in the table definition. And separate the values with a comma. Now the first one at the top here, from the top to the bottom, is customer ID. In this case, we have to look what's the next customer ID because usually that's auto incremented. So it's 1, 2, 3, 4, 5, and then the next one will be 6, the new row. Usually that's taken care of, but whenever you try to insert, it takes like a default value that's always the next in the sequence. But since we're in this environment, I have to manually type it. So I'm gonna put a 6. If you try to put 5 there, it's not gonna work. Let me just show you. I'll put 5, but it should be 6. And then let's put Anna for the first name. And I'll put Del for the last name. And then age. By the way, I'm following the sequence from top to bottom here of the definition. Put 33, and I'll put country Canada. And if I try to run, you're gonna see error, unique constraint failed, customers.customer ID. So what's happening, like I told you, there can be no other row with the same unique primary key. So the primary key customer ID that belongs to the table customers. So whenever you see this dot, just think of the column name on the right-hand side belongs to the table on the left-hand side, which is customers. And there's a constraint that failed that's called a unique constraint. So if you can apply a unique constraint to a certain column so that there can be no other value for that column. And usually that's always the case for primary keys. You want it to be unique. Otherwise, it would, like you'd have two records the same thing. How would you distinguish? Anyway, I'm gonna change 5 to 6 because that's the next one. And you can see the right-hand side that the data has been inserted. Okay, so let's try. So we can add other people, just change put 7, John Doe 47 from, let's put 8 UAE. And you can see there's no unique constraint for name because 2 or more people can have the same name. So this John Doe here is from UAE and he's for 7. Okay, let me teach you the explicit way of the longer version of the inserting too, because this one is kind of implicit for the columns here. So before values, we're gonna have to specify the name of the columns in any order we want. For example, let's do the original order. Customer ID, type the column names, separated by a comma, last underscore name, age, and then country. Okay, so here in this case, we got to match the order as they appear. And if you want to change the order, that's fine too. You can, for example, swap last with first name here. That way you could type the last name first and first name afterward. But to do that, you got to make sure your right-hand side values here. You have to swap your Doe with John. So Doe has to come first. So you got to match the order as they appear. For example, customer ID has to match the first value on the right-hand side, and then the second on the left-hand side has to match the second right-hand side, and so on. Okay. You got to change the unique constraint to 8. And let me put another name, Art. There you go. And you can see the first name is still first name and last name for last name, despite we having swapped the order here. So that's the more explicit version. If you don't know exactly the order of the columns, which usually you don't right away get like a nice interface like this showing right away. Usually you have to ask the database, can you describe the column for the tables? Okay, now like, can we delete records? I'm gonna teach you how to do that. All right. So delete from is the keyword. And then you're gonna say the table name. But then you gotta watch out. This by itself will delete all the rows, which is something you never ever want to do usually. So be careful using this. Always want to add a filter here where some column value. And typically it's always the primary key because we know for sure we're only deleting one thing. So if you try to delete by the last name, for example, you could unintentionally delete all the people whose last name was specified, despite you only wanting to delete one person, right? If I were to delete, let's say, okay, Betty wants to be deleted from the system for some reason. So if you were to say last name is Doe here, it's gonna not only delete Betty, but everybody else that has the last name Doe, which is unintentional. You never want to do that. I will do it just for the sake of example. You see they're all gone. People last name is Doe. So never do that. Let me refresh. Usually you don't get this. So I refresh to reset. So what you want to do is you want to use always the primary key, customer ID. In this case, Betty is 5. So you're very safe to only delete one row. So you know for sure it's not gonna have unintended consequences. All right, so that's pretty much it. Delete from a table name where primary key equals some value. So you're very safe from deleting anything else. Okay. Now let's talk about update. Update from, and then you gotta give the table name, customers, for example. Let's say David Robinson moved from the UK to Canada. So we need to update his country. How do we do that? Well, update from customers, we're gonna set country, Canada. But if I do it just like this, everybody will go to Canada, which is not what I want. So like delete from, we gotta add a where. Don't forget. I'm gonna do it for the sake of example. If I do that, uh, what I messed up, the syntax. Delete update from customers. Let me see. Set country, Canada. Sometimes I forget the syntax. Oh no, that's not. Oh, there's no from. Let's try that. Sorry about that. We often like forget some details. Anyway, there you go. So everybody's going to Canada now, which is not what we want. So I'm gonna reset just for the sake of this. And I wanna always add the where here. And then we got usually it's the primary key. To be safe, it's only gonna update one row, right? Customer ID. And was it David that I said? Yeah. If it's David Robinson, and I'll change this to Canada there. Now, this nice interface allows me to see the data right away here. Obviously, in an actual production, there'll be millions of rows, and I wouldn't have it on the side, so I'd have to actually query, right? Select star from customers where customer ID is equal to 3 to confirm that it was indeed changed, and I can see, okay, Canada is there. And now that I'm in that thing about me forgetting the syntax, let me give you a nice resource. This one is very nice. If you're learning SQL and you want to do some exercises, I recommend you see this one, w3schools.com. And it gives you all the syntaxes. And even if you've done this for a while, you might forget how to do things. And you can look it up. For example, the one I just forget, update. Gonna go there. Okay, update. Okay, there's no from. Set, and then you can see the syntax and where. And you can even try, I think, a demo database somewhere here. So a very nice resource. Of course, you can always make a search in your search engine. How do I do this in SQL? Or you can use the now artificial intelligence, AI chatbots and ask them as well. Okay, go back here. Great. Now let's talk about combining tables. So you might have noticed, so we have customers, and customers, they order something. This is the e-commerce store or something. We have a table of orders here, so we can select star from orders to know what people have ordered. Okay, somebody bought a keyboard, a mouse, monitor, and so on. Now, I don't know exactly the information about the user who bought this. Well, I do have the customer ID here, but that doesn't tell me their name, possibly their address and age and so on. Why isn't the customer information available in the orders table? Because when we do SQL and relational databases, we isolate each piece of resource in its own table. So there's only one single source of truth, and there's no like data being copied and pasted to another table. It'd be a mess. Imagine if you change the customer data in one table, it would be out of sync with all the other tables that all had also copied the same data. So because of that, we always keep things like we have a table for customers, we have a table for orders, and separate every single resource. Now you might be asked, okay, how do I need a way to see a report with order information and customer information alongside. Do I have to do it by eye and okay, customer ID 4, I got to do it to the customer table, look it up for, okay, John, whatever, and then how do I combine everything? That's called join. So we do joins, SQL joins, to combine tables together to provide a report for the information you're seeking. So let's say we got orders, we need to add information about the customer, but how how do we initialize that? Well, first you gotta, when you have tables that point to another resource in another table, we have these columns called foreign keys. And for example, the order for the keyboard here has customer ID 4. This customer ID column is a foreign key that points to the primary key of the customer's table, which is customer ID. It just happens to have the same name, but they don't have to be. And you just look it up. Okay, customer 4, this is the row that's supposedly going to match as we're going to join. Now, this kind of join where we match the foreign key of the primary key of the other table, it's called the inner join. Okay, so we're going to do here, select start from orders, and then we're going to inner join. That's the keyword. And then the other table, customers. Now we got to say on keyword, and you got to match the columns. Okay, on, let's say we want the customer ID of the customer's table to be equal to the customer ID of the artist table. But you might have noticed they have the same name. This is going to be ambiguous. If you click run, you're going to error ambiguous column name. Because they have the same name in the different tables, we have to specify which table you're talking about. So you got to say here customers dot to say this is the customer ID column of the customer's table. I want to match with the artist table dot customer ID column. Okay, so that's how you get around that. You want to be explicit. Now you're going to see this here, which is the combined tables. And I'm going to annotate. The way I think about this is I highlight this here, the left-hand side. That comes from orders. And the right-hand side is the actual table for customers. So that's how I think about it, if you can see my annotation. So visually, I combine the tables side by side, but it's actually matching on the customer ID here. If you notice, they always match on the customer ID. And that's how you got information for customers and their orders. Great. You might be asked, how do I eliminate the customer ID that's twice appearing? Well, you have to actually manually type all the column names that you want to see here. So you would have to manually type order ID, item, amount, customer ID, but it's going to be ambiguous. So you got to say either one of them, maybe customers dot, doesn't really matter because it's the same. And then first name, last name, and so on. I think there's age and country, like that. And now you can see there's one less customer ID. And then you can like print this out or send this to the person who asked for that information. Obviously, it's going to be a lot more than this in the actual data set. So you might want to limit or not, depends how many orders there are. Okay, and you can do by date as well. If there's like a date, like you don't want to deal with past orders, you would add a where the date like is like last 30 days or something. It basically the you put the date is greater than some like time 30 days before the date of 30 days, something like that. All right, so that's the inner join. Let me talk about SQL Venn diagram because I always show this very useful. We not only have inner joins, but left and right and other kind of joins. Let me copy image link and open a new tab, paste to the Zoom chat. So this kind of join here that we did was the one in the middle here, which is called the inner join. If you look at this, it has a Venn diagram, which is basically a set A and set B. And think of the set A as table A and set B as the table B, in this case, like orders and customers. And if you want to match them, like customers who have orders, it'll be the intersection, which is the highlight here. And then you read the code here, which is the query that would do that. Select and the table column names from the table A, inner join table B on A dot key equals B dot key. So you can copy that. Mind you, this kind of inner join doesn't give you customers who didn't order anything, right? So if you're looking to generate a report of all the customers and their orders, there are some customers who might not have ordered yet. Since there is no matching ID, they'll be excluded from the report. But if you want to include them, you could maybe do this left join. Depends on how you think about it. It could be this left or the right, right? If customers is A, you can do the left join, right? If customer is A and B is orders, so this would mean, okay, the one in the intersection would be the customers who have orders, right? Because they're both in the customers table and in the orders table. But there's some customers might not have an order. They'll be exclusively in A. That's why the A is highlighted here. You include that as well. So that's a left join. So you just change the keyword from inner to left. So you gotta think about your problem first in terms of set in order to select which if it's left, inner, or right. Okay, and there's even full outer join and full outer join like this with everything and everything by the intersection and so on. Okay, but I would say the most common one is the one in the middle that people have to know at least. Okay, great. Now let's see. I taught you how to count already. So let's talk about creating tables. You might know, okay, these tables have already been created for us. Is there a way we can create our own tables? Yes. So you can do create table statement like this, and then give it a name. For example, let's keep track of cars. I can create a table called cars, all lowercase, and then parentheses. And typically we write it with readability. We can break a line like this, semicolon at the end, and then for each line we write the column description. For example, we need to keep track of the car make, so we write the column make, and then we need a type. Car make is just a sequence of characters, could be var of 255 characters. If you don't know how many characters at most it's gonna have, just put 255, and you can change later if you need. Okay, then I can do model, car model as well, keep track of that, var as well. And you can go on. There's so many attributes of a car that we can keep track of. Maybe the year is an integer, right? And finally like that. And then you can click run SQL, and it should create a new table of cars here. Now, if you want to comment out SQL statements, you can press Control. Let me see. You can use the dash at the beginning of the line, and that would be ignore. So if I do that, it's not going to try to create the table again. It's just ignoring the code. It's like a comment. I just leave it there for reference. Let's insert into cars, right? What are the columns? We got make, model, year, values. So we got, let's say, Ford, Focus, 1992, and then run SQL. It will add that there. And then it can keep adding. There's no unique constraint, so this, if I repeat that, it's gonna add more and more. And I forget, we always have a ID that's unique, right? So primary key would have to be added as well. But that's the gist of it. And then you can do whatever we did before. You can select star from cars, and it should give you all of those. And you can delete, if you want to delete the duplicates, let me delete from cars. This would delete everything, so maybe it's kind of hard to delete because they're all the same. There's no unique primary key. But anyway, if I do that, it's going to delete everything. So that's why you always need a unique ID, have something to delete for. Yeah, so if you want to alter a table and add new columns, you could also do that. Let's say I were to add a column for the color of the car. So I would say alter table, cars, add column, and then let's call it color. And color is just var 255. And you can do that. And you should see a color column there. So you can do insert into cars. Let me do Honda Civic 2010, color red, semicolon. And you can see it's there. Okay. Now let me show you how you can play around in your own computer. If you install Postgres, it should also come with a pgAdmin, a graphical user interface client. And let me show you what it looks like. So pgAdmin looks like this. So you can here, if you don't have a server yet, if you expand, you don't have one, by default, you can right-click register server and give it a name, and then connection, it should be localhost here. And you put a password if you have set up a password when you install Postgres. And it should use the default role call or username called Postgres and the Postgres database. Anyway, after creating that, you should be able to see it here. And you can expand to see all your databases. So, okay, so we got this databases, and you can go here. You can try stuff in the default one called Postgres. This is the default one. So you can expand, and you should go to schemas, expand, public, expand, and then finally tables here. And you can right click and create a new table if you want, or you can run SQL commands like we did. Let me show you two ways of doing that. If you click tools, there's the PSQL tool, which is basically command line. So you can go here, for example, I already have a table cars. I can say select star from cars, and it should run that for me. I had made that before, by the way. If you want to create a new one, you can do it here. Create table cars, and it would type the whole thing. Let's say make var char 255, like that. And let's, for the sake of simplicity, I'll call it cars 3 because I have cars already. And that will create a table. If you refresh here, it should see it here. Or you can describe it here. If you want to describe, you can say \d space cars 3, and we'll give you information about the column for the table. And if you do \d, it gives you all the tables and sequences. So this is the command line version. If you want the graphics, of course, you can look here in the side and refresh every time you make something new. And you can expand to see the columns here and other stuff like constraints. Okay, now the other more graphical way of doing that, if you click tools, query tool, that one is like more in line with what we've been doing, right? Like in the graphical user interface, I can do select start from cars 3, semicolon, press the button play or the keyboard key F5, and I'll see that there. there's no record, so you might want to insert into cars 3. Oops, values. What's the make? Honda. And you press play and it should insert. And then you can either select star again, star from car 3 here again, press play, and you should see Honda there. Or if you want to do the graphical way, you can right click cars 3, view/edit data, and you can choose, for example, all the rows. It will basically run select star from cars 3. By the way, they always add this public dot, which is the public schema, but you don't have to type that explicitly. And it's Honda. So it's very nice thing. I think this one you can even edit on the spot, I think. Let me try. Maybe not this one. Honda 2. Yeah, this one doesn't let me. But sometimes you can if you make a query here, I think. Query tool, select start from cars 3, semicolon. And I like to edit that. Sometimes I don't know why it's locked. Strange. I wonder why. I could click the other stuff here. Click this. Don't save. This X. Let me close the other ones. So if you do scripts here, you can, maybe you forget how to do SQL. You can actually get all this stuff. For example, I forget how to do insert. I can right click scripts, insert script, and it will write everything for me here. It will write all the columns and the values, and I just have to change the question mark with here, Toyota, for example. And it should insert for me. And there you go. All right. What else? So creating tables. If you were to create a table, you can do it like manually, or you can use the graphical user interface. Right click, create table. For example, let's do car 4. And choose the owner and then columns, and you can add them here. For example, make. And it's going to be, in this case, a varchar, but here it's called character varying, but it's the same thing. Character varying. Don't put the square brackets, without. And you can give the 255, which is basically the parentheses. And you can add more, click plus, and so on and so on. Like if you want to add like a primary key here, you would choose either serial if you want the primary key to be integer, or big serial if you want the primary key to be a big int. Let's do serial. And I'll just call it ID. And you can mark here this not null, which is a constraint, meaning this value needs to always be defined. It cannot be empty or null. And then you can check it's a primary key, yes. And if you do that, it's gonna do all this job to create the table. And if you right click properties, click columns again, you can see it's become integer with this next val for the default, which is basically taking for a sequence that's created when you have primary keys. If you expand that, actually it's outside here, sequences. You have a sequence for cars 3. If you right click that, it's just keeping track of the increment for the primary key and the maximum value. Anyway, what else? Yeah, if you forget how to create a table, you can right click scripts, create script, and it will actually give you how the commands to create the table. Of course, there's some additional stuff you shouldn't really care about, like collate and whatever here, and the sequence stuff. Usually you don't need that, but you can see the definition of the table in manual SQL here. So very useful if you forget SQL, want to refresh your memory, what's doing. Okay, so basically pgAdmin is just a front for calling SQL queries behind the scenes. So instead of you manually typing the queries, you just click, make some clicks, type some stuff, and it will ultimately generate the SQL and execute that for you. I didn't mention that, but let me try creating a table again. Cars 5 with a table column make here, just so I can show you it's actually doing that. If you go to the last tab and click SQL, it's actually showing you what's going to run when I click save. So it's basically going to run create table, cars 5 with the make column as a character variant, which is basically varchar. So you can play around and change, okay, let me change 255 here. What happens in a SQL? Oh, it adds parentheses 255. Okay, if I add another column here, year, and I put integer, what's going to happen in the SQL part? Click SQL. Oh, it adds year here and the integer. So you can play around, see what's actually going on behind the scenes and learn SQL along the way. So very powerful tool to use, pgAdmin. Okay, so I hope that's interesting to you, and I'll call it a day.